This webcast talks about how to complete Part 1 of the lab Conservation of Momentum. In Part 1, we look at explosions, and we're going to use this online simulation tool at the physics classroom. So if you would please go to that URL, and you will be on this page. Click on the words Launch Interactive. And then a little bit down, you see you've got a box that says Exploding Carts, and we're going to click Begin to look at this simulation. Okay, so in this simulation there are two carts, and they are initially stuck together, maybe with a piece of Velcro or something like that. But they are each equipped with spring-loaded plungers. And so when we click the word explode, those plungers push back on each other. So each cart pushes the other away. And so then you see the two carts roll to the various sides of the page. And we can change the mass of both the blue cart and the red cart. And let me just just explode it first to see what happens. So I'm going to click explode, and the carts move away from each other. When they finally have gone off the page, you can see the post-explosion speed in centimeters per second. So we can see that both carts, because they had the same mass, moved away from each other with the same speed, but they moved in opposite directions. Okay, so there is an Excel template which you can download from the web page, and we're going to use the first tab, the tab on the left that says Data Part 1 Explosions. Okay, so I'm going to set the mass according to what it says in the data table, and then I will record the post-explosion velocity of both carts. Okay, so initially both carts should have a mass of 0.5. So I'm going to go back to the Exploding Carts simulation tool. I'm going to reset it, and I'm going to change each of the masses to 0.5 kilograms. And now I will explode. And then I can see the post-explosion speeds. Okay, so be careful. These speeds are given in centimeters per second, but I want to enter my data in meters per second. Since there are 100 centimeters in every meter, I need to divide these speeds by 100 to have the speed in meters per second. Okay, and then also notice that this simulation tool is telling me speed. Speed is a positive scalar. It is not a vector, but I want to record my data as a velocity, which is a vector. And so the blue cart is moving to the left. It's moving in a negative direction, and so I need to record its velocity as a negative amount. Okay, so I'm going in my table to record the blue cart's velocity as negative 0.6, right? Because I made it negative since it's moving to the left, and I divided the 60 by 100. The red cart was moving at a positive 0.6. Okay, and okay, so I've recorded that data. To fill out the rest of this table, I will just in turn go and change the mass of the carts to make them match this, run the explosion, and record the velocities. Let me do one more in this webcast. I'm going to change the red cart mass to 1.5. Okay, so I reset. The only thing I'm changing is the red cart's mass to 1.5. I leave the blue cart at 0.5 kilograms, and I explode it. I see the blue cart moving faster to the left. The red cart is slower. And here are the speeds. So the blue cart, the velocity is negative 0.6. and the red cart's velocity was 0.2, right? 20 divided by 100. Okay, so you will do that to fill in the rest of this table. I'm going to go ahead, though, and talk about the rest of this part 1. Okay, so we have started getting data. Okay, so in step 6, it says the red cart and blue cart are initially at rest. Show the detailed calculation of the initial pre-explosion linear momentum of the system that consists of these two carts. So the initial momentum of the system, so I'm going to put an I there for initial, it ought to equal the initial momentum of the blue cart plus the initial momentum of the red cart. Well, the initial momentum of the blue cart is the mass of the blue cart times the initial velocity, maybe I should say blue initial. And the momentum of the red cart is the mass of the red cart times the velocity of the red cart initially. Okay, the mass of the blue cart was 0.5 kilogram, and its initial velocity was 0. It was not moving. The mass of the red cart was also 0.5 kilogram. I'm doing this for the first row in my data table, and the initial velocity was 0. So I have 0 plus 0. The momentum of this system at the beginning was 0 kilogram meters per second. Okay. And then I want to show the calculation, I'm moving on to step 7, of the post-explosion linear momentum of each cart. Okay, so for the blue cart, the final momentum equals the mass of the blue cart times the final blue cart velocity. Okay, so the blue cart had a mass of 0.5 kilogram, and at the end, after the explosion, the velocity was negative 0.6 meters per second. And so the blue cart had a final post-explosion momentum of negative 0.3 kilogram meters per second. Similarly, for the red cart, the final momentum would be the mass of the red cart times the final velocity of the red cart, which is 0.5 kilogram times a positive 0.6 meters per second. It moved to the right, and so its momentum was a positive 0.3 kilogram meters per second. In step 8, it says, okay, what was the post-explosion momentum of the system? Well, the momentum of the system at the end, so system final, equals the momentum of the blue cart at the end plus the momentum of the red cart at the end. So it equals negative 0.3 kilogram meters per second plus 0.3 kilogram meters per second. It equals 0 kilogram meters per second. So the momentum after the explosion is 0, the momentum of the system, and the momentum before the explosion was 0. So we have the same amount of momentum both before and after the explosion. And you'll notice that in this Excel template, it has the formulas already to calculate this, and so it is showing me the final system momentum is 0 for this first case, and for the second row of our table as well. Okay. And so I'm going to leave it to you to collect 10 data points, and we'll continue in the next webcast.